Hi again, everyone. So in this video, we're going to take a look at this example problem. Oops, sorry about that. Which will have us find the slope and the y-intercept and also interpret what they actually mean. And we'll also get some practice with defining units and identifying a slope as a unit rate. Alrighty, so let's take a look at the y-intercept first, because that's usually a little bit easier. So we can see our y-intercept on each of these graphs. It's nice and easy to just visually see it on our graph. So we can see here our y-intercept, or b, that would be equal to 4. Likewise, we can see here on this one that our y-intercept, well, so we want to check our scale. It looks like every tick is 10. And so I believe plus 2 more, that would be at 170. Oops, b equals 170. And likewise down here, it just hits at the origin. And so that would mean that b equals 0. Okay, so let's take a look at what these are actually saying. In this scenario, question number 1, or graph number 1, we're looking at, okay, the height of a tree on the y-axis, and on the x-axis is the year since planting. So remember, when you're at the y-intercept, x equals 0. And so in this case, if it's the year since planting, that would tell us that this tree, was, or the baby tree that we planted, the tree was 4 feet tall when we planted it. I think that makes sense. Okay. Let's see. Notice, well, actually, hold off on that for a second. Our bank balance here is on the y-axis, and the time in months is on the x-axis. So we can maybe imagine that this is you started off with some amount of money in your bank account, and then every month you spend some money. So if that's the case, then let's see, I could say that I opened the bank account with $170, because dollars is what's on the y-axis here. Now we don't actually know what the story is behind this graph. So for all we know, maybe it's just your initial deposit, or maybe, I don't know, it could be any number of things. And lastly, for part number 3 over here, let's see, the distance traveled in miles is on the y-axis, and on our x-axis it's gas in gallons. This kind of looks like how much, if you have some amount of gas, it tells you how far you can go. So if I don't have any gas, in my car, you can't go anywhere. In my car, I can't go anywhere. Which, I mean, that's not really the worst thing in the world right now, because you couldn't go anywhere anyway. But that's neither here nor there. Also pay attention to the units here. Notice, because we're looking at just a y value here, remember b is the y-intercept, so it's a y value. This says y equals 4 feet. And here y equals $170. And here would say that y equals 0 miles. So the units on the y-intercept should actually be the exact same unit that your y variable is being measured in. Okay, so I want to keep that in mind. If we look at the slope now, well, let's actually calculate the slope. I always need 2 points for the slope. So let's see, the point on here, it looks like I only have one, 514, but I also have the y-intercept right there. And so if that's the case, well, my delta y, I could just draw on the graph here. My delta y, well, it would be 14 minus, so I'm going to pretend I'm going, starting on the bottom one and then going going right and then going up. Let's see, my delta y would be 14 minus 4, which is 10. That's my delta y. My delta x, that's not so bad. That's 5 minus 0, which is 5. And so my slope on this one would be 10 over 5, which is 2. I'm going to kind of just fast forward through the next two, but you should check your work with my end results. Okay, so I calculated my slopes here. For the second one, I got -10, and for the third one, I got 44/2. There's a reason I wrote it like that, so stay with me. Okay, in this first one now, my slope was 2, but remember, when we're talking about a situation like we have here, we definitely want to put units on this. So if I go back to the original idea here, what's going on, my rise, again, that's a change in y. And so that tells us, well, let's see, 14 feet minus 4 feet is still going to give me 10 feet though. And so my rise is actually 10 feet. Similarly, along the x-axis, well, we were measuring time in years. So this is 5 years as my delta x. So when I actually evaluate this and kind of figure out what this means, is that this tells us, hey, our tree, the tree grows, how far? Well, it grows 10 feet, assuming it grows, and we'll assume it grows constantly. It grows 10 feet every 5 years. Now, we wouldn't really want to say that because it just seems kind of awkward. So the question we should ask is, how could I write it as a unit rate? Or how much does it grow in just 1 year? And that's how you get where you would simplify it. Another way to say this, as a unit rate, the tree grows 10/5 feet every 1 year. Right? Now, we wouldn't say that either because you would just simplify it, but in other words, it would be 2 feet every 1 year. And again, the way I did that was I need to get the denominator, the bottom of the fraction, to be in just 1 year. And so the way I did that, let's see, 10 feet per 5 years to reduce this fraction, but I can't actually change the value. I just divide the bottom by 5 and the top by 5 is basically what you did. And that gets 2/1, 2 feet per 1 year. And that's what you want when you're talking about it as a unit rate. Okay, I just realized that's what I was trying to get to with this one, but it's good. So I kind of just did it there. This one, if it's -10, well, this one's weird because in units, it would be -10 the dollar. I don't know where the dollars would go here actually. Dollars per, as a unit rate, dollars per month. Now again, this, if you looked at it like so, you would have said it went down $20 per 2 months, or, $10 every 1 month. And so if it's negative, that just tells us that we're losing money. We lose, or spend, well, I guess not we, I guess. I lose $10 each month. And last but not least, on this last one, let's see my slope. Let's see, this would be, I'll go back to this idea. Let's see, I could go 44 miles. 44 miles for every 2 gallons of gas, GALs. Or as a unit rate, this tells us 22 miles per 1 gallon. They'll just divide top and bottom by 2. Right? And so, well, actually, let me actually write that out for you. I apologize. Divide the top by 2, divide the bottom by 2. Again, it's important that we do do the same thing to the top and the bottom, so we don't actually change the numerical value. 22 miles per 1 gallon. What this essentially is that, so for every gallon of gas I can go, or my car can go 22 more miles. if we think back to like the actual situation in terms of what does this tell you about your car, this would tell you the car gets a gas mileage of 22 mpgs, and you hear about this when you see car commercials or hear car commercials on TV or on the Spotify or something. Alrighty, so that's how we can find, well, one, find the slope and y-intercept on a graph, and also figure out what they actually tell you in terms of an actual situation or context, and two, to identify the slope as a unit rate. Thanks for watching, folks. I hope this was helpful, and I'll see you in the next video.